My name is Miro. I will talk to you a little bit today about debugging Laravel apps with a focus on performance. So at first, a little bit about me, very quick. I've been writing software for about 15 years. Most of it doing like freelance work on different web apps. I used everything from vanilla PHP to different frameworks until I ran into Laravel 4 beta, which we tested on a big project. It was a great success. I never used anything else after that. Currently, for the last few years, I'm working as an apps lead in Garulata, which is like a local tech startup here in Bratislava. We do kind of social media monitoring on a large scale. We use all kind of tech from Python to Go and Rust, but for our end user apps, we still use, we build them as Vue.js SPAs with Laravel API, since we think this is the best tool for the job. I'm also an open source developer. My main project is called Clockwork, which is a debugging tool for Laravel, which is, I guess, where the passion for this topic comes from. So we talk a lot about how to build apps well, but that is only one half of our work. The second half we spend debugging. So it's actually also equally as important to talk about debugging and learn some approaches to make us more effective. In this talk, I will start with a little bit of kind of a theory introduction, and then we will take a look at 5 scenarios that are kind of like real-world inspired performance issues. We will try to diagnose them and improve. So why does performance actually matter? Why do we do this? First of all, we should not only build the working apps, but we should build apps. We should aim to build apps that are pleasant to use. It directly leads to better making more money, better conversions, better sales. There are studies made where even 1 second delay can lower the conversion rate on the website. It can have some direct implications, for example, for search result ranking. Slow code is literally more expensive to run. If our app is too slow, we may need to scale to more servers. If it uses more memory, we might need beefier servers with more memory. These things cost money. And in general, it's just a nice thing to not waste energy and CPU cycles. So some, in general, thoughts about performance. It's not just, optimization is not just about performance, it's in general optimizing the system resource usage. For example, memory is also like a rare resource which is limited. So performance optimization comes with trade-offs. A lot of times when we optimize heavily for the performance, we increase the memory usage. For example, we need to load the whole data set to memory because that's how it's fastest to work with. And on the other hand, when we optimize for memory, we sometimes need to make the app a little bit slower. So it's kind of a careful balancing act of balancing all the different system resources we have available. So to know if our app is even slow, we need to determine some performance targets. For example, in Garulata, I might think our endpoints, we aim to have at most like 250 millisecond response time, and if there's some endpoint that takes more than 250 milliseconds, it's kind of like a suspicious, and we should investigate. But these are kind of moving targets. For some endpoints, even the 250 milliseconds is too much. For some that do like a serious amount of work, they may need to take even like a more than several seconds. We should also keep performance in mind when we are even designing the features on the application. Sometimes even small complication in a new feature can have like a huge performance impact. That's why it's important for the developers or someone with deeper technical knowledge of the app to be involved in the design process itself. The performance requirements change over time. As our users grow, our data in the database grows, the app might become lower and lower performant. So it's important to think about future, think about scaling when writing code. But at the same time, it's important to not overthink it, because all code can be removed and rewritten better in future. It's also important to think about like local specific slowness when developing. For example, we might be accessing a database via VPN, which is much slower than it will be in production. We might be using artisan surf, which uses like super low performant built-in PHP HTTP server. In general, it's best to try to mirror the production environment as much as possible. So next, let's take a quick look at some tools that are available for debugging, and especially for performance debugging. First of all, some built-in tools in Laravel itself. Everyone used written some DD statements. It's sometimes the quickest way to debug something. There's nothing wrong with it, but it might not be super practical in many modern use cases like SPA. Where we would need to look for the dumped value somewhere in the debug tools in the network tab. Dump is the same things. It just doesn't stop the execution. We can use the dump server to redirect the dump from the output to terminal, to console. Which is kind of cool. There's also like this SPACY array product, which is kind of like a nicer GUI version of this. Another great tool that's included in Laravel, which we don't usually do enough, is logging. Logging creates kind of a paper trail of what is happening in the app. So a lot of the issues don't show up in development, but show up later in production. And it's great to have some logs to go back to and see what actually happened in the app that triggered this bug or this slowness. And also, while I was working on this presentation, I found out this Laravel Pale package, which is kind of like this console command which shows live the last log messages, which is kind of cool. But the application is actually kind of a black box. We send some HTTP request, something happens, and it spits out some response. For example, this is kind of our main API endpoint from Get Platform API. We can't really tell what's happening from this code. We might think it runs, there's some query references, so we might think it runs some SQL queries. We can take a look inside the monitor class and we will figure out it actually runs some Elastic queries. But we really have no idea just from looking at this code or spending like 5 times in the code base, or 5 minutes in the code base. This endpoint actually runs up to 3 Elastic queries, a bunch of SQL queries. For some requests, it might even make like API requests to external services. So we actually need to use some additional tooling to gain a little bit of insight into this application black box and see what's happening. Now, our first alternative is Laravel Telescope, which is a first-party solution for this problem. It kind of adds this web UI to your application, which logs all the made requests, and then you can inspect the details of the request to figure out like what queries have been run, what kind of events have been fired, what log messages have been logged, and pretty much everything that happened while processing that request. Another alternative to this is the Laravel debug bar, which is the most popular choice. It kind of injects this kind of toolbar in the output of your application, which you can open, and it shows kind of the same things as Telescope. And another alternative is Clockwork, which I might be a little biased because I made this, and it's similar to Telescope. It also has like a web UI, and it also can be installed as a Chrome DevTools extension. And sometimes these tools are not enough, and we have to go deeper. That's when we use something like Xdebug, which is a PHP extension, and it includes a step debugger, which can be integrated to many of the popular IDEs and gives you the ability to set breakpoints where the execution stops. You can check out the contents of the variables, see what's happening. It also includes profiler, which kind of collects all the executed functions, methods, so you can see how much time did they take, how many times they were being invoked. This is very useful for finding the more kind of edge cases where the slowness is in the PHP application logic itself. And also, if you don't use Xdebug, you are not a professional developer. Another kind of alternative to Xdebug is SPX, which is also a kind of extension for profiling. It has like a built-in UI with these nice kind of flame graphs, pretty useful. It's also recently been added to the Laravel Herd, the kind of newest local development environment from Laravel. The last category of tools we will need to use are the continuous monitoring tools. Since bugs also happen in production, unfortunately, also a lot of the slowness is only found in production. That's why it's important to use something like Bugsnax entry. There are a bunch of alternatives. They all kind of do similar things, so it's a matter of preference. Which one do you want to use? There's also this inspector dev tool, which seems to be focused more on Laravel and for kind of continuous performance monitoring of Laravel apps. And Blackfire.io, which is built by Symfony people. And the cool thing about this one is it includes kind of like Xdebug like a profiler with much better and easier to use UI. Another kind of relevant thing is this OpenTelemetry thing. It's kind of like a standardized way to collect metrics and observability data. It has integrations for various languages, multiple different apps to visualize the data. So this is kind of useful if your stack has a lot of moving parts and a lot of different languages. For example, in Gerulata, our stack might have like 40, 50 different services written in like 6 languages. So this is kind of useful to track like what's happening in the whole stack. So let's move on to the second part, which is kind of like these real-world inspired scenarios of performance issues, and we can try to solve them. So first one, the user's endpoint. It's my amazing drawing. We are working on like a Vue.js SPA. We have this kind of select component for user, which includes his avatar and name. When you click on it, it fires an API request to get all the users. When it comes back, it renders the list of the users. We kind of noticed it's a little bit slow. It's not like too bad, but it's noticeable. It makes the app feel slow for the user. When we look into the implementation of the controller, there's a little bit sus thing about loading all the users, but in this example, we only have 50 users, so it's not actually the case of the problem. There's nothing like super suspicious otherwise. So what we do if we want to see what's happening and diagnose the issue, we will open this in Clockwork in my case, but it can be Telescope, it can be Debug Bar. It's just a matter of preference. So here we see this request in Clockwork, and immediately in the timeline there's a kind of suspicious thing. There's this 101 database events. So when we click on the database tab, we can immediately see we are executing actually 101 queries for this simple list of users. And when we look at the query list itself, it's kind of obvious what's happening. It's the classic n+1 query problem, where we forgot to use some eagle loads, and we are lazy loading in a loop for each user's his avatar from the media table and some invoices which we don't even use. And when we go back to the model step, we see we are actually making 2,500 of these invoice models. As you can see, actually, hydrating the models is a big part of the problem. Even when we are making a lot of extra queries, the query time total is only 10 milliseconds since I run this on like my local MacBook, fast MacBook database. But instantiating all these invoice models takes some time also. So when we go back to the code and look at the user resource that we use, we can notice the problem. We are using the getFirstMedia URL, which is a method from the very popular package sparsely Laravel media library, which is used for uploading images and associating them with models. And internally, this package uses this media table for tracking these uploads. So that's why it's important also to understand how the packages we use work under the hood, because otherwise we can introduce performance problems in our code that we don't even know about. Other than that, we also include these invoices for this user, because we are using this user resource also in like different places on our code base. But for this like simple select of users, it's not relevant at all. So let's try to fix this. So we fix this by, for the media thing, we actually need the avatar. So we just add it as a eagle load. And for the invoices, we actually don't want to include them at all. So we will use this when loaded resource helper method to only include the invoices when they are already loaded. Now, when we go back to Clockwork to see if this works, yeah, we can see that now it only takes 22 milliseconds, which is much better. Check back the database tab, and we can see the invoice queries are gone altogether, and the media queries were optimized into a single query thanks to the eagle load. So this is like a very simple, it's kind of like level 1 performance issue, but everyone makes it from time to time. I make it all the time. I find it in our own apps in different endpoints. We forget to eagle load something and it runs unnecessary queries and it's just slow for no reason. We can also use this option to actually prevent the default Laravel behavior of lazy loading the relationship when it's not loaded. And then Laravel will actually throw an exception when we try to access a relationship that we forgot to eagle load. So that might be actually a good idea in local development. Okay, so we have let's go to the second example, top members endpoint. In this example, we are building an app that kind of tracks different Facebook groups. And for each Facebook group, it shows some details, including this widget of top members, which shows the members who posted the most content in this group. And this actually takes like 5 seconds to load for some reason. And when the user navigates around the app, it always like refreshes this widget, and he can see, or she can see the kind of like spinner for 5 seconds all the time. It makes the application look very slow. Let's look at the code. It doesn't actually matter like the details of this code, but what it does is it runs a very expensive Elastic query to figure out who the top posters are for this group. And when we take a look at it in Clockwork, we can see like the post request is actually the Elastic query being run for almost 5 seconds. This is, we can also see it in the HTTP tab and look at the details, including like the query details. We already like optimize this query as much as possible. So there is really nothing we can optimize here. So let's look at some ideas how to solve this. We could pre-compute this daily in some scheduled command. This is kind of a good idea, but we are monitoring hundreds of thousands of these groups. So for most of these groups, nobody is going to check these top members. So it's a lot of unnecessary work to do every day. The second idea is to simply cache the result, which actually works really fine in this case. We just use the cache remember, very convenient Laravel API, give it some name, and for some TTL, in this case, we cache it for 1 hour. Now when we make the request again, for the first request, we can see the Elastic query was still executed because it's not cached yet. And in the cache tab, we can confirm that we missed the cache, it was empty, and a new value was written. And any subsequent request is now like super fast because we just read the results from the cache and don't hit Elastic at all, which we can also confirm in the cache tab. Now, good use of caching can really like alleviate the load on our servers. For this example, if we are expecting like 1,000 requests for this group, without the cache, we would spend total 83 minutes of querying Elastic for this group, and with the cache, we now only spend 5 seconds. So caching is very useful when we want to do some resource-intensive work only once, and then use the results later for subsequent requests. Laravel has like many backends to support storing this cache data. Databases may be only useful for like simple things or like local development. Redis is usually like a good choice, and there are a couple of others. And there are a lot of nice APIs to work with it, but we don't really have time to go into details. Instead, let's look at another case. This case is called booking a trip. So in this case, we are working on like a website to buy kind of like a summer vacation trips that include a flight, transfer to a hotel, and a hotel room. So kind of the flow on the website is we order some trip, we pay for it, and then we get to this page where the actually booking is done for our flight tickets, hotel room and stuff, which is kind of like this expensive API request. We need to communicate with a bunch of external APIs. They are all very slow for some reason. And when we stack these all API calls after each other, they actually take a very long time. So if we look at this in Clockwork again, we can see how the API calls are executed after each other, and it adds up to more than 13 seconds for this API request. So let's go to some ideas how to improve this. We could just do this work later and then send, for example, an email to the customer that it was done. That's actually kind of common for most eShops. So you get like update later that your order is actually processing or done. Or we could do more fun stuff and use queues. So this original implementation change for queues. In the controller, we only dispatch 3 queue jobs for the flight, transfer, and hotel. And we do the actual work in the dispatched queue job itself. We also include this booking update event to let the front end know that the booking was updated. And the cool thing about this is now the HTTP request itself is very fast. It does pretty much nothing. And we can scale up the queue to many workers. So when we have 3 workers, we can process all the bookings in parallel. And that means that the booking is done when the longest duration booking is done. When we check it out in Clockwork, we can see the first request now takes only 22 milliseconds. It does like nothing. It just dispatches these 3 jobs. We see it does some inserts into jobs table because we are using the database backend in this case. And we can still like inspect what's happening in these queue jobs, and we can see the expensive API requests are still happening inside there. The queues are kind of like one of my favorite features in Laravel. I use them on like every app I've made pretty much. They are very useful to offload the expensive work from the HTTP request itself to like a background queue worker that can scale independently of the web server. It doesn't need to even run on the same server. You can have like a separate set of servers for workers and scale them up. There are many backends to store these queue jobs, like database. Redis is, again, a very good choice. And there is also this package called Horizon, which is kind of like a first-party alternative implementation of the queue worker. And it includes some like more advanced configurations, and it also includes this web UI monitoring dashboard for your queue. I tend to use this one on pretty much everything. Okay, one more is generating Excel export. It's one of like the most common tasks we can do in a web app. In this case, we just Googled the most popular Excel library for Laravel and use it. It looks kind of like this. We are exporting some invoices with like very simple styling, pretty much nothing there. But it actually takes like a super long time, and it eats up a lot of memory. The memory part here is the bigger problem. I tend to run my PHP instances with 256 memory, like maximum memory limit, so this would actually fail on my server. This is caused by the underlying Excel library used in this Laravel integration. It's the PHP Office one, which is like super feature complete. It includes like every Excel feature possible, but it's also kind of slow and very memory intensive. So let's think about how can we do this better. We can again pre-compute these exports kind of ahead of time in a scheduled command, but then when the back office staff wants to download this invoices export, it wouldn't include like the latest invoices. We can again use queues and build some UI to track like what's happening, the progress of the export. That's kind of expensive, a lot of work to do, especially on the UI part. So we can simplify that to just use the queues and send the export by email. That's actually kind of a decent solution. But in this case, we might also look at different Excel export libraries. And we will find out there's actually one that's much more effective. It's called Baum, or the Laravel integration is from Sparsy. It's called Simple Export. And it's actually much faster, and especially much less memory intensive. When we look at this everything code endpoint with the new library, we can see it takes about half the time, but the most important part is it only takes 14 megabytes of memory compared to more than 256. So this library is much better, seems to be much better, but it comes also with some drawbacks. It only supports some very basic styling, so it's very like can't be used in all cases. In this case, these exports were only made for some like back office stuff, so they don't really care about the styling that much, and they care more about the export being fast. So it was a good solution in this case. very quickly, last one, the rendering of list of products. This looks like a super simple thing to do. It's just a list of products rendered as table with a bunch of some of their attributes. This is how it's implemented. So the first kind of SaaS thing is we are again loading all products, but we have only 500 products in database right now, so it's not a big deal for now. There's also some like curious decision made in the database design where whoever designed this database decided to store all the attributes in a single JSON field, which is then casted to an array. But it's kind of weird, but doesn't seem very problematic for now. And in the template, we just kind of print out the ID name and a bunch of stuff from the details array. Now, if you look at it in Clockwork, it's kind of slow for no reason, apparently. Like the queries take only less than 1 millisecond, like the database time total is 2 milliseconds, the memory is slow. So in this case, let's go to the Xdebug to see what's happening. So we run this with the Xdebug profiler enabled, and now we can see what actually methods were executed and how much time was spent executing them. And when we sort it out by the most expensive methods, we can see a lot of stuff from the eloquent model class like getCast, hasCast, getCast type. A lot of stuff that seems to be doing something with casts. And when we open this same profile in this kind of crazy looking Q cache green app, we can see for example, the getCast method was called 121,000 times in processing this request. If we investigate further and look in the Laravel source code, we will find out that the casts are actually not done when the model is hydrated, but they are done on access to the attribute. So every single time we print something from the details array, it goes from JSON decodes the column and goes through all the internal APIs in the model to handle the casts, which is the problem here. So some ideas how to improve this, of course, better database design. Probably shouldn't store everything in a single JSON column. We can bring in some server-side pagination, and we can also just add a workaround. So we can just cache the cast in like a temporary variable for each loop, and this decreases the amount of times that needs to be casted by like 40 because we are referencing this details field like 40 times on each iteration. When we go back to Clockwork, we can see this really helped. All the expensive methods have disappeared and the response time goes down considerably. So Xdebug is useful in the case where the bottleneck is actually in the application logic itself. When it's kind of like mysterious bug, we can't really find it. It adds a lot of overhead to the running script, so we should also think about that. And if we want something with a lot nicer UI, we could use the Blackfire IO. That's pretty much it. For some further resources, there's kind of recently released a book, Performance with Laravel. I kind of skimmed it while preparing this presentation. It's decent. The Laravel Skills in Action by Mohamed Said, who's on the Laravel core team, is pretty good if you want to go deeper into queues. And then the Laravel documentation itself, which is very well written. And of course, don't be afraid to look into the source code. You will learn a lot of things and how to work better with Laravel. Yeah, that's it. Thank you.
Thank you very much, Miro, for your wonderful insights and for the tips. We have questions. Again, I would like to encourage you to use the Slido and add more questions. Yeah, I will see it maybe. Okay, so Do you have any experience with performance or load tests? Yeah. And if so, what's your opinion on them?
I'm not 100% sure what is meant by this. Maybe like using something like AB or some like of these like load monitoring tools. Sure, they are good at measuring like how many requests we can. It's nice to have some hard data on how performant our application is. So definitely, I encourage using any of these kind of tools.
Okay, thank you. Are you also using Nuxt or just Vue SPAs, or do Vue SPAs mean inertia?
So actually, we use pure Vue SPAs. We don't use Nuxt. We don't use inertia. They are built. They are like separate repository built completely outside of Laravel. Laravel is purely just an API in our case.
Okay. And also, what's your opinion about Livewire?
I don't like it.
Okay.
But it's useful for like simpler stuff. I would use it. If you don't want to commit to building like whole Vue SPA for like a simple website that needs to be a little bit dynamic, Livewire is completely like a good solution.
Okay, can you talk a little bit more about the clockwork? Like, because there is a question like about version 6. So how long has it already been developing it? Or
I think I've been developing it from 2013. So the current version is 5.2, and 6 will be released by I have no idea when.
Okay, cool. Are there any questions? If no, then I would like to thank you again, and
thank you.
Please give Miro a round of applause.